Hello everyone, welcome to another video of my channel. Today we'd like to discuss on k closest points to origin problem. This is an interesting DSA problem and it will be very fun solving this problem. We'll be solving this problem using min heap, so let's get started. At first, let's see what does this problem say. It says given an array of points where points I means it will have an abscissa and an ordinate which will represent a point on the xy plane, and will also be given an integer k. What we'll be returning is the k closest points to the origin. So as all of us know that the Euclidean distance, usually in order to find out the distance between two points on xy plane, we use the Euclidean distance. That means this one. That means the difference, the square of the difference between the abscissa of 2 points plus the square of the difference between the ordinates of 2 points and the square root of it. So we'll be using this formula in order to find out the distance of each points from the origin. Since here origin has ordinate and abscissa of 0 0, so we can neglect this x2 and y2. That means in our case this distance will be x1 square plus y1 square and its square root. And here we are given an liberty that we can return the answer is in any order. Just we have to make sure that the first k or the k closest points are being returned. Let's see some example. Here it says 1 3 and 2 4, and from these 2 points we'll have to find the closest one. So here distance between 1 3 from the origin is square root of 10, and that of minus 2 2 is square root of 8. Since square root of 8 is more closer to origin than square root of 10, so here minus 2 comma 2 will be our answer. Let's see another example. Here we are given 3 points, but we'll have to find out the first 2 closest point to the origin. So it says that 3 3 and minus 2 4 will be the first 2 closest points. Now let's try to solve this problem. As we have already said that we will be using min heap, so what we'll be doing is we'll be taking an STL C++ standard template library named priority queue, and it will act as a min heap. Usually the priority queue in C++ is a max heap by default, but we can make it work as a min heap using the greater comparator like this. So we'll be using the priority queue, or we'll be defining our priority queue with our greater comparator. Then from the list of the coordinates, for each coordinates, that means for each points, we'll find out the Euclidean distance. And our priority queue, that will be a priority queue of type pair. Pair means we'll take two type of things together. Here one type will be the distance, another type will be the index of the coordinates, or simply the index of the points in that array. Now what we'll be doing is, for each point at first we will be finding or calculating the Euclidean distance and make a pair of the distance with that index of the point in that array, and we simply push it to the priority queue. Thus we will apply this same procedure for all the points in the array. Now it's time of getting the k closest points. As we are using a min heap, so here if we pop the very first element, we are guaranteed to get the smallest distanced pair. So if we pop this priority queue k times, we are guaranteed to get the first k closest points to the origin. So we'll simply do it like this. We'll pop out from the priority queue k times to get the required points. Here we can see 3 points, and from those 3 points we will have to find out the 2 closest points to the origins. At first we find out the distance of the first point from origin, that is square root 18. Now what we do is we store this, make a pair of this distance with the index of this point, that is 0, and we push this pair to our min heap like this. Now let's calculate the distance of the second point and also push it to the main heap. So this will be like this. Now it's time for the third point. This is it. Now we are done with pushing pairs to our main heap. Now it's time to pop the first k, that means first two pairs from the main heap. If you have a look at these sqrt values, we can say that square root 18 and square root 20 are the two smallest. That means the points 3 3 and minus 2 4 are the closest to the origin. So thus we get our answer. Now let's solve it in Leetcode and see what happens. Let's submit it and see what happens. So we got accepted, and our runtime is quite faster, and also our space complexity is also quite good. Thanks for watching the video. I hope you have found this video useful. Happy coding, guys. Thank you very much.